Okay, the marketing staff at Texas State Bank in Dallas is planning to roll out a new marketing campaign addressed at increasing bank card use. As one part of the campaign, the bank will offer a low interest rate incentive to induce people to spend more money using its charge cards. However, the bank is concerned whether this plan will have a different impact on married cardholders than on unmarried cardholders. So these are my two groups, two populations: married cardholders versus unmarried cardholders. So prior to starting the marketing campaign statewide, the bank wishes to test the concept on a random sample of 30 unmarried and 25 married customers. The managers wish to estimate the difference in mean credit card spending. So this is the goal, to estimate the difference in mean credit card spending for unmarried versus the married customers for a 2-week period immediately after being exposed to the marketing campaign, right? Based on the past data, data analysts in the marketing department have reason to believe the spending distribution for unmarried and married customers will be approximately normally distributed. Listen, the first assumption has been met in the question. Both populations, they have normally distributed curve. But they are unwilling to conclude that the population variances for spending are equal for the two populations. So the variances are not equal now. The variances are what? Not equal. If you remember, we have three assumptions. The first one, both populations have to be normal, which is okay. The second one, the variances of the populations, they are not equal now. So that's why we can use the other method, the new or the adjusted formula. The third one, the both samples, they have to be what? Independent. In this case, they are independent because we have unmarried versus married, right? So what to do? We are going to go to stat, basic statistics, to sample. We have summarized data, yes, so we are going to go to put the summarized data. The sample size for the unmarried, where is it? Unmarried, we have 30. We have 30 here. We have 25 here. Sample mean 455.1. Here we have 268.9. The spending, right? And now the standard deviation of the sample is this. First sample, second sample is this. We go to options. We have to build 95 confidence interval estimate, which is 95, that's fine. And what is the hypothesized difference? We assuming that mu1 minus mu1, there's no difference, 0, right? And the alternative hypothesis is the difference is not equal to the hypothesized difference. The difference is not 0, basically. There is a difference between the two populations, the unmarried and married. Maybe one is spending more than the other one, right? Assume equal variances? No. Take this off. Then okay, then we're done. Then what we got, basically, the confidence interval is 137.5. The 95% confidence level for the difference is what? Excuse me. It's 137.5 between $137.5 and $234.9. So the goal was to estimate the difference in mean credit card spending for unmarried versus the married. And this one doesn't contain the 0. Listen, this interval doesn't contain the 0. So what we can conclude, oh, maybe there is a difference. Maybe there is a difference in the mean. We're going to study this. But this one doesn't contain the 0, right? So there's an evidence that the unmarried customers, after being introduced to the marketing program, spend more than married customers on average, because we said the unmarried minus the married. The unmarried minus the married give us really, there is a difference. There is a difference between both of them. The unmarried customers spend on average more than the married customers, from $137.5 to $234.9 in the 2 weeks following the marketing campaign. Right? So this is the kind of the conclusion, because why do we conclude that the unmarried spends more than the married? Because this one doesn't contain the zero, so there's no way that the mu1 is going to be equal to mu2, right? The question is that because of the campaign? Is that because of the campaign is really effective, or it's more effective for the unmarried compared to the married customers, or no? Maybe we have to look at other factors like their accounts, the customers' accounts before the marketing campaign. So these are something else. But in general, it's clear from the our analysis that our analysis says that the unmarried tend to spend more on average between this to this compared to the married people. So maybe we can write this somewhere here. There is evidence to conclude that unmarried customers, after being introduced to the marketing campaign, spends what? More than the married customers on average. Between what and what? Between 137 point whatever we got dollars and $234 in the 2 weeks following the marketing campaign. This is customers here. So this is the conclusion. There is a difference. The idea is there is a difference between the population means, because the zero is not within the interval. This is important to understand. The zero is not within that interval.